Welcome to the Spirado group. First of all, we are going to talk about simple harmonic motion slash elasticity. Some topics that are usually coming out in your 2026 what WIC. Now, this is going to be what retort stand and the spring balance roller masses. So we are going to check. First of all, we are going to measure the what. From it, we are going to measure the length of this, which is referred to as L naught. And you can see for our length is about 9.2, 9.2, or better still, even though if fix it here, still the same thing as 9.2, okay, let me fix it this way, it's still the same thing, 9.2, okay, 9.3, so I'm going to put it there. I'm going to put it there, 9.1. Now, we still talked about, this is what we did. Now, since 9.3 from our experiment, from our L naught, and then we'll fix this. This is what, 50 grams. So let's see what will now be the new mass. What will now be the new mass? Fix it here. You can see that it extends a bit. And so the new mass is going to be, exactly 10. So let's check. And 10 is going to be written there. That's for 50 kg. So 50 kg is 10. Let's assume, okay, now we are adding kg is 10.00, usually in 2 decimal points. And then let's add something of this. And let's see, and that 50 kg, so it becomes 100. That's 100. Let's see how it's going to be. Let's see how far. Just kind of oscillating. Let's try to pause the oscillation. 50 kg is 10. You can see in this case it is 15. Okay, let's see. You can add, it's going to be 15. So let's see when here is at 100 kg, and let's add this to it, becomes 150 kg. At 150 kg, wow, there's a lot of increase. At 150 kg, at 150 kg, let's see what it's going to be. It's going to be 22.5. 22.5, look at it. 22. So you can see the 22.5 being written, 22.5, and then at this 150 gram, and when we had 200 gram to it, and that 50 gram making it 200 gram, let's see how the length is going to be. 200 gram is going to be 200 gram. It's going to Sophia. Let's see how far. Oh, sorry, the pin was removed. Of course, it can be 200 gram. And 200 gram. Let's see what it's going to be. It's now becoming more elastic. 200 gram. Try not to interfere with the experiment. At 200 gram, you can see that it's going to be what? 29. At 200 grams, it's going to be 29. Let's see, going to be 29. And at 250 gram, and was added 250 gram. Let's see what it's going to be. 250 gram. At 250 gram. Let's see what it's going to be. 250 gram. 250 gram. Just that the spring is not getting more elastic. 250 gram is going to be this 250 gram, we're going to check what it's going to be, trying to make sure it didn't interfere with the experiment. Okay, 250 gram, so this one is kind of bent. Let's use this area of it. It's about, so if you say it's about 35, 36, 37, about, okay, 30, because this one's coming, 36, 250 grams is about 36, oh, 30, sorry, hold on, 35.6, sorry, 35, this 36, 35.6, 35.6, so we're having 35.6, so all this has been done. Then what should we do? We remove our mass, and in this aspect we are going to check for the extension. And for the extension, remember our original length was what? Our original length was 9.3. So we are going to be checking and subtract what? 10 from 9.3. 10 minus 9.3, which is 0.70. 0.70. And we'll see, check or subtract what? 15 from point what? 9.3. 15 point what? 9.3. I want to see 5.70. Show me. I want to see. The next one we're going to talk about 22.50 minus what? 9.3 is going to be what? 13.2. The next one we're having, 29 0.00 minus what? 9.3 is going to be 19.7. 19.7. And also we are going to talk about 35.6 minus what? 9.3, and we're going to see what? 26.3. So you're going to see the trends, so you can observe 5, 13, 19, 26, 5, 6, 7, 8, 9, 10, 11, 12, 13, 13, okay, 13, about this, it was about this, about 6 was added, 8 was added, and this one is about how many was added, about 6, this one is about 19, 20, 21, 20, 24, 25, 26, about 7, so it's kind of quite close. So we are going to plot a graph of what? The mass against the extension. Plot a graph of the mass against the what? Extension. Okay, which is to say what? The extension should be on the vertical. The mass is going to be what? E on the vertical axis against what? M on the horizontal axis. E on the vertical axis against what? M on the what? Horizontal axis. That's one. So secondly, the whole of this can be repeated here. Let's see how it's going to be repeated. So show me, put it down, and let's see what we can do towards that. So we're going to say mass when it's 50 kg, 50 gram, and 100 gram, 150 gram, 200 gram, 250 gram, and so on and so forth. So the length is still the same length as 10.00, 15.00, 22.50, 20. This one is for a special, this one is one experiment. We can still repeat on that form of experiment using pendulum, harmonic motion. So you can put it harmonic motion is for elasticity. So put this experiment on elasticity. This one is for harmonic motion, or both of them can be done at the same time. So let's see what we can have here. Hold on. To repeat the same experiment, I remember that time it was about 9.3, so which was about 9.3 here, and we are going to have a maximum displacement 9.3. So shift to this side. Let's see what we are doing. So but now we are going to check, going to talk about more of pendulum and fix our mass and you can see that the thing displays and becomes what? 10. 10 in, like the other one we have, you see having about 10. So we are going to displace it by what? Can be 2, 1, 2, by 2, and check our displace by 2, and then check. You can see like this. Let's see our displacement. Okay, let's displace it by 2, 1, 2, and we're going to check our time, and let's see how far it goes. This is our stopwatch, and you can see it at the same time. Let's see what we can do. Go. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Hold on a bit. Let's see. We are going to see repeat. Let's make it, because it's not properly this. Okay, it's not. 2 is okay. Just trying to check how far the. So we're going to displace it by 2, 1, 2, and let's see the displacement. So we're going to see 1 to go, having it go, which is go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it's about what? 4.57 what seconds. Let's see, put it down. 4.57 seconds, and let's see add the other weight. 4.57 seconds. So the second weight is being added, and you can see when the other weight is being added, we are going to displace it by 2, and let's see how far it goes. First one was 4.57 seconds, and let's see. Start. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It's 5.47 seconds. 5.47 seconds. 7.47 seconds. 7.47 seconds. 7.47 seconds. So we are still adding the third one to it. You see about this? So we are going to add it. So we see that at this end it's going to come down a bit. And once it comes down with a little bit displacement, 1, 2. So the displacement is about 2. Let's see how far it goes. So let's see. 10, which is go. Okay, sorry. Let's see how far. Let's come back again. The experiment was kind of 1, 2. So let's see. Go. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This is about 8.74 seconds. 8.74 seconds. So we're going to put the next mass when it's at 50, 100, 200. Okay, 150 to 200. So you can see how it is. Here it is. So we're going to extend it to 2, 1, 2. So let's see how far. So you can see, okay. Let's see how far we're going to get. Go. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It's about 10.16. Well, let me repeat this one. I'm not too sure. 10.16. Let's see again. 10.16. This is how it is. 10.11. So 10.16. 10.16. Let's see how far it goes. 10.16. Let's see. Go. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10.32 or 10.16. Yeah, can you make use of the same 10.16 or 10.32? I mean, let's see how far we can go. So let's see the next one. When the other mass is being added to it. So let's see. You can see mass is being added to it. So we're going to displace it by 2. 1, 2, 2. And then let's see our measurement. We're going to leave it. You can see how it is. And then go. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Let's see 10.96, but we are going to repeat it again because it hit the calculator. Let's see how far it goes by 2 displacement. So we're going to see, let's see by there, 1, 2. So let's see how far it goes. So you can see, let's go. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 11.36. 11.36. 11.36. So with that, you can observe that this is how our experiment is being conducted. And then what are we going to do from what we are having? We're going to be having divide, because it's 10 times we counted, which is 10 oscillations. We're going to divide this by 10. So 4.52, 4.57, sorry, 4.57 on cheat, divide it. 4.57, 4.57 divided by 10, which is about 45. Okay, 45, 0.47. Okay, all these things are just easy. Divide by 10, shift the decimal point backward. 0.457, put it down. 0.457, 457. The next one, 0.57. 0.57. If you divide this by 10, okay, divide this one by 10 is 0. Is what? 7.47 divided by 7 divided by 10 is about 0.747. 0.747. 0.747. So the other ones is, if you follow the trend, it's going to be following the trend. It's going to be 0.874. The next one is going to be 1.032. Next is going to be what? 1.136. These are how it's going to be. So the next one, I'm going to find square of each answers. So we're going to say 0.457 square. Square is going to give you 0.209, which is 2088. 209. 0.209. 0.209. The next one we're having 0.747 square. Got it? Square. We're having going to be 0.5580, which is 0.558. 0.558. 0.558. Next is having what? 0.874. 0.874, you can see, and we are going to find the square of it. It's going to be having 0.7638, which is 0.7639. 0.7639. Okay, 3976. Okay, 0.764. Okay, in 3 decimal point. Let's see the next one. We're having 1.032 square. We're having 1. Okay, so if it's 1.02 square, it gives you 1.065. 1.132 square is going to give you what? 1.290. So you're going to plot a graph of what? T square on the what? On the vertical axis against what? M on the horizontal. That's the first one. That's the first graph. Also the second graph, T square on the vertical against what? The extension on the what? Horizontal. That's the second graph of it. And then you find a what? Slope of every what? Thing. So with that, I call this Desperado TV. Do endeavor to share, like, and comment. Thank you very much. This is how we experiment to go. Bye.